Hi everybody, this is Dr. Hamid with your Math 120 College Mathematics class. Today we are going to talk about section 8.4, which is about compound interest calculations. Okay, so in 8.3, section 8.3, we talked about simple interest calculations. Okay, so today we are going to extend it to compound interest. So in this compound interest calculations, our goals are to introduce compound interest formula. I will emphasize on the difference between the simple interest and compound interest calculations. Okay, and then we'll talk about how we want to use the compound interest formula with one compounding, more than one compounding a year, or continuous compounding. Okay, we will also talk about how to calculate the present value with the compound interest calculations. Okay, and as I said earlier, we will from n compoundings a year, we will also have a formula, talk about a formula for a continuous compounding. So let's first start about related to the simple calculations of interest. uh, so the main difference between the compound interest and the simple interest is that the simple interest, it's basically a type of interest that is paid only on the original amount deposited. Okay, the interest we earned, okay, that's a different story, that is not added to the next cycle of calculations. Okay, on the other hand, when we talk about compound interest, it is sort of an interest on the interest as well. It is a method of calculating interest where the interest is added to the original principal as well. Okay, so if you if you suppose you invest $1,000 into the bank, okay, for the simple interest, no matter for how many years you invested, okay, your interest will always be calculated based upon the original amount. But when we talk about compound interest, when if you at the end of 1 year, okay, whatever you interest you earned in the next year's calculation, that will take into account as well. Okay, so you will get interest on that as well. So here, here is an example, a graph. It explains how your money grows with the simple interest and with the compound interest. You see that for the first few years, it's basically the same, but after some time, as the time evolves in years, you start to see the effect of the compound interest. Okay, uh, and since we each time when we use the compound interest formula, okay, uh, we we add the interest as well to the original amount, and as a result, our interest gets bigger. Okay, and the next time that interest is also included into the original, and then we calculate, so the graph starts to go up here. Okay, so the compound interest is definitely better than the simple interest. Now let's talk about some terminologies and compound interest formulas. Compound interest, as you already know, is the interest computed on the original principal as well as on any accumulated interest. Okay, to calculate the compound interest paid once a year, okay, so there are different forms. Your compound interest can be, you can have it paid every month, you can have it made n times, you can have it paid 20 times. So let's start it with simple. If our compound interest is paid only once a year, so this will be the formula. Formula is A equals to P times 1 plus R, and this T time is in the power here. Okay, it's in the exponent. So this is the formula here. A is called the future value of the account. Okay, that will be the accumulated value. P is the principal. Okay, R is the rate, and T is the time again, and it has to be in years as well. Okay, so this is the formula. Let's look at one example where we use compound interest calculations. Okay, suppose you deposit $2,000 in a savings account which has an interest rate of 6%. This is your question. Two questions. First of all, find the amount A, the money in the account after 3 years. Okay, future value, subject to compound interest. And the second thing is, you also have to find the interest earned. What is the interest? Okay, how much interest you earned? This is the formula we know. Okay, A is equal to P times 1 plus R to the power T here. Let's write down everything. P principal is 2000, R is 6%, which is 0.06, T is 3 years. Okay, so that is given to us here. Plug everything back into this one since we want to find the accumulated value, the future value. So P there, R there, T there. First you add these two up, then you take the third power of 1.06 and multiply by 2000, and this is what you get. Okay, so you get $2,382 and 3 cents. Okay, so this is your accumulated value or the future value of the account. That's what your first part was. Okay, now the second part is find the interest. So you started with 2000, okay, and you ended up with 2382. So what will be the interest? Interest will be the difference of the two. Okay, so whatever the difference between what you started with and your current value, that will be the interest. This much is the interest earned in 3 years, which is $382.03. Okay, so this was the simplest calculation involving a compound interest. Now let's get to little bit more complicated things here. Suppose instead of interest calculated at once a year, suppose it is calculated more than once a year. Okay, multiple times a year. So to calculate the compound interest paid more than once a year, our formula will change to this one here. Okay, if you notice that everything else is same, just this n is added, n r over n and n in the exponent. So this n is a new parameter here, and I will tell you what it is. As I told you earlier, a is the future value, p is the principal, r is the rate, and t is the time in years. And the new parameter n is the number of times the interest is compounded per year. Okay, so if it is compounded twice a year, n is 2. If it is compounded thrice a year, n is 3. Okay, if it is compounded 6 times a year, n is 6. So how many times it is compounded a year, that will be your n. So let's look at an example again. Suppose you deposit $7,500 in a savings account that has a rate of 6%, and the interest is compounded monthly. Since there are 12 months in a year, so n is equal to 12. Okay, and how much money will you have after 5 years? That's your first part. And the second part is find the interest after 5 years, how much interest you earned. So for the first part, let's write down whatever we have here. P is equal to 7,500, R is 6, which is 0.06, T is 5, and N is 12. We know every piece in the formula. This is the formula. Put everything in there. So P 7,500, R 0.06, N 12, N times T is 12 times 5. T is 5 there. First you will solve this fraction, then you add it to 1 and you get 1.005, and then when you multiply 12 times 5, this is 60, and then you use your calculator and take the power of 1.005 to the power 60. Whatever the answer is, you multiply it by 7,500, and this is what you get. Okay, so this is your future value after 5 years. You start with $7,500 and you end up with $10,116, a little bit more cents. Okay, so this is your this much money you will have in the account after 5 years. Next question is find the interest after 5 years. So this is what you started with, this is what you have now, so the difference will be the interest. Okay, so this is the interest earned in 5 years, which is $2,616. Okay, approximately. So that's how you will use the compound interest formula with more than one compounding. Okay. Okay, now let's extend this formula one more time, and this time instead of having n compoundings, we'll talk about continuous compounding. Okay, so now some banks use continuous compounding where the compounding period increases indefinitely. After t years, a balance A, the accumulated value, in an account with the principal P and annual interest rate R is given by the following formulas here. Okay, this is the formula for n compoundings a year. We already know that. Okay, we talked about this, we used it, we did example with this formula. Now if we take n going to infinity, okay, so for the continuous compounding, then we have this formula becomes a equals to p e to the power rt. Okay, so if you calculate the limit here as n goes to infinity, this is what you get. Okay, so e here is the Euler's number, and all of know e is equal to 2.7182 and goes on and on and on. And there's a button on the calculator which you can press to get this e here. So okay, so it's a famous base. So if you want to extend the formula for continuous compounding, this is your formula. A is equal to p times e to the power rt. Okay, now let's look at an example here. Suppose you decide to invest $8,000, okay, for 6 years, and you have a choice between two accounts. First one pays 7% per year compounded monthly, okay, and the second pays 6.85% per year compounded continuously. So you want to decide which one you should choose, okay, which one is the better investment. Remember that we have two choices here. One is compounded monthly, okay, so n is equal to 12, and the second one is compounded continuously. So for first part we will use this formula here, okay, and for the second part we will use this formula, and you will see which one we will choose. Obviously whatever yields more interest, that's what will be our natural choice. Okay, so the better investment will be the one with greater balance at the end of 6 years. That's what we want to choose. So first option is with monthly compounding. N is equal to 12, p is equal to 8,000, what we start with, r is equal to 0.07. okay, so put everything in there and do the calculations. This is what you get, $12,160. so this is what you get for n compoundings, 12 compoundings, monthly compounding. For the continuous, if you use continuous compounding, so this is a is equal to p e to the power rt. okay, principal is 8,000, e to the power rate times the number of years. If you work this thing out using a calculator, you get $12,066. so which one is better? Okay, of course first option is better. Okay, first option with 7% interest, it and monthly compounding is a better investment because it gives us more money at the end. Okay, so we are investing it to increase it to the maximum. Since this one gives us more money, so we will go with this option. Okay, so that's the better investment. Okay, now let's twist this formula a little bit around. Planning for future. Okay, so that's what the title is. This is the formula here. Okay, a is equal to p times 1 plus r over n, everything to the power nt here. Okay, with a little bit of work, we can rewrite this formula in terms of here we have a equals to this. We can have p equals to this. Okay, so p will be our present value. Okay, so now after a little bit of work we can get the formula which will give us the present value p that can be used to achieve a specific saving target with the calculated present value. So if you want to solve it for p, just divide both sides by the extra factor. So it will be a over everything what we had with p here. Okay, we divide both sides by this factor and you get this formula. This is called the present value formula for with the compound interest. I think I have example. So how much money should be deposited? Okay, so we want to find out what we should start with. Okay, so that's what the goal is. So how much money should be deposited in an account today that earns 6% compounded monthly, so that it will accumulate to 20,000 in 5 years. So our goal here is 20,000. So at the end of 5 years, we want to have 20,000 savings there, and we know the account we are going putting it's 6%. Okay, how much we should start with? So that's what the goal is. Okay, so we already wrote the formula. Formula p is equal to a over 1 plus r over n nt. If we know how much we want the accumulated value, this is our target, which is 20,000. And then put the interest rate, compounding, time, work this whole mess out, and you get that 14,827. Okay, so approximately 14,827 should be invested today in order to accumulate the target. Okay, so to accumulate 20,000 in 5 years. So that was a sort of a reverse application of this compound interest formula. That's it. Thank you very much. Three things in this lecture. Okay, compound interest. Okay, compound interest with the n compoundings, compound interest with continuous compounding. Okay, so three formulas, little bit more work. There are problems of each kind in your homework. Please make sure to try those. If you have any questions, let me know and I'll explain more. Thank you. Bye bye.